Alright, LeetCode 200, number of islands. You've got a two-dimensional grid of ones and zeros. Ones are land, zeros are water. Count how many islands there are. An island is a group of ones connected horizontally or vertically. Diagonal doesn't count. Take this grid. 3 rows, 3 columns. 1, 1, 0. 0, 1, 0, 1, 0, 1. The top left one connects right, and that connects down to the middle. That's one island. Bottom left is isolated. Second island. Bottom right is also alone. Third island. Answer is 3. Now the tricky part, if you just scan and count everyone, you'll overcount. The top left cluster has 3 ones, but it's one island. You need a way to recognize connected ones belong together and count each group once. Here's the key idea. Think of each one as a node in a graph. Adjacent ones share an edge. Counting islands is really counting connected components. The classic tool for that is depth-first search. The strategy is simple. Scan every cell. When you hit a 1, that's a new island. Increment the counter. Run DFS from that cell, visiting every connected one and flipping them to 0. This syncs the entire island so the scan won't count it again. Each island gets counted exactly once. Let me walk through it. Our grid is 3 by 3, 1, 1, 0, 0, 1, 0, 1, 0, 1. Island count starts at 0. Scan from the top left. Row 0, column 0 is 1. New island found. Count goes to 1. Now we run DFS to sync it. Starting at the top left, row 0, column 0. Flip it to 0 so we don't revisit. Check 4 directions. Up is out of bounds. The cell to the right, row 0, column 1, is a 1. Go there. Now at row 0, column 1. Flip it to 0, right is 0. Down at row 1, column 1 is a 1. Go there. Now at the center cell, row 1, column 1. Flip it to 0. All 4 neighbors are 0 or out of bounds. No unvisited land left, so DFS returns. First island is fully sunk. Grid now looks like this. 0, 0, 0. 0, 0, 0, 1, 0, 1. Continue scanning. Everything is 0 until row 2, column 0. That's a 1. New island. Count goes to 2. Run DFS. Flip it to 0. All neighbors are 0 or out of bounds. Single cell island. Keep scanning. Row 2, column 2 is 1. New island. Count goes to 3. Flip it to 0. Also, a single cell island. The grid is all zeros now. Return 3. Time is big. O of m times n, where m is the row count and n is the column count. We touch each cell at most a couple of times. Space is big O of m times n in the worst case for the recursion stack. If the grid is one giant island, the call stack goes that deep. No extra space beyond recursion since we modify the grid in place. Here's the full code. Found this useful? Master key interview patterns at AlgoMonster and land your dream job.